Good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Group's main meeting. So tonight, you've got me. We're going to talk about Azure Synapse Analytics. We're going to talk a bit about security. And of course, if you have any questions at all throughout, please do drop them into chat. I will have chat right in front of me. You're right here with me, chat. So get your questions in. We'll talk a lot about Azure Synapse Analytics. Before we do that, though, I do have one thing that I probably should link to, and that is a survey. In case you have not yet received the email, you probably won't receive the email if you haven't already, but sent out an email not too long ago with a bit of a survey for the Triangle Area SQL Server Users Group. We send one of these every 2 years, and it's about survey time. So what I want to do is drop a link in chat right now. Let's get that in there. And if you have a chance, please do fill it out. It helps us drive the direction of this group over the next couple of years. So very appreciative for any additional survey responses. Otherwise, we're going to get things going with a quick introduction. Hello, everybody. My name is Kevin Fiesel, if you don't know who I am already. I run a predictive analytics team here in Durham, North Carolina. I happen to be the voice behind most of these TriPass meetings, and that's mostly because I have the equipment, and that's what I'm here doing. But tonight, I'm talking about a topic of my own, and I also want to push curated SQL. The idea of curated SQL is every weekday, I try to find and link to 5 to 10 interesting posts on topics all around the data platform space. So it's curatedsql.com. What we'll do tonight is get a high-level overview of Azure Synapse Analytics security. I will give you a warning. If you want the full version of this, it's 8+ hours. I know that because I've done it. That said, we will hit many of the high notes. Network security, workspace security. We'll talk a little bit about outside resource connections and getting into the 3 major pools. You may say to yourself, but wait, there's a 4th pool. I've got a slide for that. So let's get going with a primer on what Azure Synapse Analytics is. In case you're not that familiar with the topic, Azure Synapse Analytics, this is Microsoft's platform for modern data warehousing. And there are 4 separate data sources, like I mentioned. The first one is the dedicated SQL pool. The idea of a dedicated SQL pool is essentially, I have a warehouse, a classic Kimball-style warehouse with facts and dimensions, except that I have a whole lot of data. The you must be this tall to ride the ride line for a dedicated SQL pool, approximately 1 terabyte of data, minimum, and your fact tables, you should have at least 1 fact table with about 1 billion records. That's how you start making the best use of a dedicated SQL pool. Now, the dedicated SQL pool cops aren't going to pull you over and inspect your tables and make sure you've got 1 billion rows in them, but you may be spending money that probably would be better used in other services if you have fairly small warehouses. So, intended to be classical data warehousing with very large amounts of data. Spark pools are intended to run Apache Spark. So, I mean, based on the name, we would kind of figure that. Now, in Azure Synapse Analytics, you can use Spark pools for a fair amount of work, but I think that they are best used for data transformation projects. So I have some sort of data flow that's coming in, and I want to use Spark languages, Scala, Python, Java. I want to use maybe .NET, F#, C#. I want to write SQL queries. R is, I think, I shouldn't say anything out loud without Googling it. So guess what? We're going to Google Live because that's the kind of presentation we're getting tonight. So, because I think I read something about this not too long ago, and I don't know, maybe I didn't. But Python, Scala, Java, .NET, SQL, those are all available in a Spark pool. You can also perform some machine learning operations in Spark pools. And if you happen to run on-premises Spark clusters and you just want a place to run them, this is a reasonable place to do it. I also have on here, my head is blocking HD Insight, and that's for a reason. It's because I don't like HD Insight very much. Also, you could, of course, run Azure Databricks. Databricks is a great option as well. So the serverless SQL pool is our third pool. This is a bit different from a dedicated pool. That dedicated pool is for warehousing. It is kind of close to a classical SQL server in the way that we work with it. We insert data, we load data into it, we perform operations on it. There are some modifications based on the physical implementation. There are some things that you can do in a dedicated SQL pool that you really can't do on premises, but conceptually, it's pretty close. The serverless pool, quite a bit different. The serverless SQL pool does not actually store your data. Instead, it reads data from a data lake. So what that means is that you don't insert, update, delete, merge, truncate, or otherwise modify tables that are in your serverless SQL pool. Instead, you insert data into the data lake, and then you can create tables, external tables off of that data in the data lake using something very much like Polybase, but not quite the same. Alternatively, you can use a function called openRowSet, which will allow you to read files like from a data lake. So there's a fundamental difference in the behavior between these, and that behavior manifests itself in where the serverless SQL pool works best, which tends to be for ad hoc query analysis, for spelunking, searching for data within a large data set. Now, Data Explorer pools are the final type of pool that Azure Synapse Analytics offers today. It will allow you to perform real-time analysis on large volumes of data. I kind of like the Data Explorer pool, but it's still in preview. And because it's in preview, I'm not comfortable giving a lot of advice about security of this pool, and therefore we're going to ignore that tonight. So once it goes out of preview, I'll reevaluate, I'll think about how best to secure data in a Data Explorer pool. As it is today, I'm like, it's public preview, stuff can change. So real brief pool advice. You get one serverless SQL pool. There is no option there. You cannot delete it, you cannot create a new one, you cannot stop it. It is just there. Of course, you only pay if you're actively querying from it. So you're not constantly being charged for it. Create one Spark pool per relevant task. If you have some sort of data cleansing operation, have a Spark pool for it. You have some sort of machine learning op, create a separate Spark pool. Spark pools are cattle, they are not pets. They are intended to be spun up, they do their work, and you destroy them. Next time you need one, spin up a new one. So you typically don't have just one of these because, well, they're easy to destroy and recreate. One dedicated SQL pool per warehouse, although most of the time you're just going to need one of those. And to save some scratch, you can pause that pool when it's not in use. So the serverless pool, you want to save money, just don't use it. I think pricing of the serverless pool is actually pretty good. And I have a whole talk on the serverless SQL pool if you want a lot more detail there. But since we're not talking so much about money, we're talking about security, let's move on. Talk a little bit about Synapse pipelines, which is based off of Azure Data Factory's code. So these are pipelines in Azure Data Factory. That code was brought over to Azure Synapse Analytics and lets you perform extract, load, and transform, or ELT operations. And Synapse Link is our last major product in this space that we need to think about. This is our way to connect data sources. So initially, it was to connect Cosmos DB to an Azure Synapse Analytics Spark pool or a dedicated SQL pool. Since then, there have been additional connectors for Dataverse, and also SQL Server 2022 has a connector that will allow you to feed data into Azure Synapse Analytics without needing to build your own ETL or ELT jobs. So this is a fairly easy way to migrate data over. And not have to manage a lot of the ETL, especially in stable processes where you're not changing tables and columns very frequently. That's our overview. It's a really basic primer on Azure Synapse Analytics. And of course, again, if you have questions, get them in chat. I'll take them at any point in time. But let's talk before you really get into security, or before you click the buttons in the portal to say, let's build a new Synapse workspace. We got to talk a little bit about regulations. Your organization is probably tied to at least one regulatory regime, and you'll want to check out the Microsoft compliance offerings to make sure, based on your regulatory regime, that everything is copacetic. So you can scroll down here, you can find industry specific standards, you can find governmental standards in the US or abroad. So you may find that, for example, if you fall under the IT Grundschutz workbook for Germany, then as we dig down here, they can give you a feeling for what types of things you may have to do, what types of services may be affected by this. If, for example, like Sarbanes-Oxley, we can see what things are in scope around it. This is a good first resource to look at if you need to get an understanding of whether a particular service falls in scope. Some services may not be allowable given a specific regulatory regime. Most services are okay as long as you follow the rules around proper security, proper maintenance of the system. And this applies even to platform as a service offerings like Azure Synapse Analytics. The reason is there's kind of a shared responsibility here because Microsoft shows those details on compliance, but let's be honest, this is a team effort. This is not just, well, Microsoft has the regulatory approval and therefore any Synapse workspace I create will always be valid under HIPAA. And that's because there's stuff that you have to do as well. Like, for example, Microsoft is going to control the hardware. So any regulatory requirements around hardware, that's on them. They'll handle it. They've got the certifications. They've got the certificates with various governments that indicate that, yes, they're doing it the way that the governments require. You control the access because they can have great hardware, but if you just allow everybody admin access to all of your systems, it doesn't help very much. Microsoft offers encryption. You control that level of encryption. Now, sometimes you control here means whether or not a thing is encrypted. Other times it simply means, are you going to use Microsoft's keys for encryption, or are you going to use your keys for encryption? There is no don't use keys options for some of these platform services. Finally, Microsoft is in control of the network. You're not really configuring Azure networks. You can lay out virtual networks on top of their network, but the backbone is theirs. You control data. You control what data is available, what data can be accessed, who gets to access it, how they get to access it, and how you maintain that data. So there's this shared responsibility that fits into regulatory requirement. And it kind of, since I talked about data, let's cover a couple of important principles. That is, we have these various notions, and I'll do it briefly since I don't have one slide for each. Encrypt data at rest and in transit. So data at rest has been kind of a normal standard for at least 15 years at this point. Data in transit has become normal, I'd say, over the past decade. Ensuring that sensitive data is necessary to store, this is something that I do want people to keep in mind. For example, if you have personally identifiable information, ensure that you actually need that information. If there's a compelling business reason to keep it, that's great. Okay, obviously keep it. But if there's no compelling business reason, if there's no legitimate concern involved with it, then it's safer not to have that data because you can't lose what you don't have. Similarly, if that data becomes obsolete, getting rid of it is a legal protection. And preventing access to this except when needed is a good way of, say, not giving away the farm. We also want to think about business continuity. And in the SQL world, we tend to think about business continuity as HANDR, high availability, disaster recovery. When it comes to high availability, Microsoft is mostly in control here. Dedicated SQL pools, the high availability involved there is that all of these servers are distributed, kind of highly available by default. You don't really do anything for that. You don't create an availability group for a dedicated SQL pool. It's just, availability is there. The serverless SQL pool is technically highly available, yet I've seen it fail far too often. So it seems like quite a few single points of failure within the serverless SQL pool infrastructure, but technically it is supposed to be highly available. Maybe I've just had really bad luck, and the people that I know have had really bad luck, and the people that they know have had really bad luck. Spark pools are what I'll call user controllable high availability. Oh no, my Spark pool is gone. Oh well, create a new one. So as long as you have the capacity to create new ones, which usually you will, as long as you don't hit CPU limits, then create a new one, start over, let the old one die. Disaster recovery, by contrast, is more of a joint effort. So disaster strikes, where is my data? Can I recover if a data center explodes? There was recently a big data center fire in South Korea. Earlier this year, there was a big data center fire in southeastern France. Data center fires happen, and that can be a problem. So dedicated SQL pools, they're going to take automated snapshots. They have a recovery point objective of 8 hours and a retention of 7 days. So in other words, if you have this pool that's just running constantly, they're going to take a snapshot roughly every 8 hours. And they're going to hold those snapshots for approximately 7 days. Now, you may be shutting off the dedicated SQL pool for 20 hours a day, turning it on just for the 4 that you need it. In that case, you might not actually get an automated snapshot because that engine might not be running while your pool is active. So you can take manual snapshots in that case. You might also want to take a manual snapshot before a major deployment activity. That way, if everything goes completely heels up, then you can revert back to the snapshot. Dedicated SQL pools are also backed up to another region once every 24 hours. So if data center 1 happens to burn down, you have a backup in another region that is available, that is at most roughly 24 hours old. Maybe 47 hours old if the fire happened right when your backup was going on. I don't know, maybe it happens. Or that the last backup had failed. Other pools, the Spark pools, the serverless SQL pool, not Data Explorer pools, because remember that's a different topic. They store data in the data lake. So if you have data in a data lake, I do highly recommend geo-redundant storage. Geo-redundant storage is going to ensure that you have data that is in your region. It will also make a replica of it in another region for Azure. For example, if you're in East US, they'll make a copy in West US, and you'll have data in 2 different data centers in 2 different parts of the country. That's going to give you disaster recovery for the data lake, and in the event of a horrible disaster, you can spin up a new Synapse workspace over on the other side, deploy out your code, and you're back up and running with your data over on the West Coast. So those are a lot of prep options, the types of stuff that you'll want to think about before clicking anything. Now we're ready to click stuff. So we go into the Azure portal and we say, I want to create me a Synapse workspace. And when you're going through the step-by-step install for a Synapse workspace, there are 2 major options that look really insignificant. And the first option is this one right here, Managed Virtual Network. And the second one is allow outbound data traffic only to approved targets. Those don't sound all that exciting, but they are 2 of the most important options that you could take when it comes to network security. First, that first one was about a managed virtual network. If you turn this thing on, Microsoft is going to create a virtual network. They're going to have it available for you, and they do all the setup around it. You cannot create your own virtual network and have a Synapse workspace running off of it. It is either use the Microsoft network or don't have a virtual network and have it be publicly accessible. You must flip this option at creation time if you want a managed VNet. If you want to turn it on after, can't do it. So once that workspace is created, either you have a managed virtual network or you don't. That's end of story. If you turn it on without one and you need it later, go create a new workspace. Fortunately, creating a new workspace isn't that big of a deal, but it can be a bit annoying. So what does a managed virtual network actually give me? Well, there's a few things. One of them, it is going to segregate Spark pools into individual subnets. In other words, if I have Spark Pool 1, Spark Pool 2, Spark Pool 3, well, those 3 Spark pools are not going to be able to communicate with each other. That means if, say, one of them happens to have installed a malicious package, that package, and somebody gets access to the machine, they're not able to pivot over to other Spark pools. So you have that kind of subnet isolation. Next, the workspace itself is on its own virtual network. What this allows us to do is open up only the ports necessary to communicate with different Synapse services. I need to communicate on, say, port 1433 to the dedicated SQL pool. I need to communicate on these ports for the serverless SQL pool, on these ports for Spark pools, on these ports for my Azure storage, on these ports for my Azure Key Vault, and nothing else. So all of that is handled for you. This is part of why Microsoft doesn't allow for manual virtual network creation, that there are a lot of ports and services that would have to be opened up manually and controlled manually that people may get wrong. So essentially they just say, you know what, we'll do it for you. We know that we'll be able to get it right. This also enables a concept known as the managed private endpoint. A managed private endpoint is a connection to Azure resources, certain Azure resources that do not transit the public internet. So in other words, I have an Azure Key Vault. Azure Key Vault allows you to store secrets, certificates, other goodies that I don't really want transiting over the public internet, even if over TLS. Well, with a managed private endpoint, I can guarantee that all packets stay on the Azure backbone, that within Azure networks, this is the only place where those packets will transit. And therefore, nobody on the public internet is going to be able to access this. Furthermore, it creates managed private endpoints to the serverless SQL pool, as well as any dedicated SQL pools that you create. And because these are private endpoints, because this is behind a virtual network, what you can do is turn off public IPs altogether. Make it so that your Synapse workspace is not at all publicly accessible. So you'd have to go through a VPN or some other mechanism to connect and get your data connections that way. Really good for a corporate environment where things need to be locked down. AWS VPCs cost about 5 cents per gigabyte. Microsoft charges for virtual networks, right? Yeah, there are virtual network transit costs. I'd have to look it up to tell you exactly what it is, but it's probably either going to be about the same as AWS or within 1 or 2 cents either way. Sometimes AWS is a little cheaper, sometimes Azure is a little cheaper, but usually they're about similar pricing for these types of backbone services. Now, the last thing, in order to get data exfiltration protection, we need a managed virtual network. So what is data exfiltration protection? Well, this is that one strangely phrased statement. Allows outbound data traffic only to approved targets. Data exfiltration protection essentially says, oh, this data should be in my Synapse workspace. I don't really want it to go outside unless there's a good reason for that. And good reason may not be a developer's reason. So the short version of my opinion, it does work. It will really prevent you from moving data out from Azure Synapse Analytics in bulk, but it can be limiting to developers. It will prevent you from doing certain activities like installing packages on your Spark clusters from the internet. You can't use pip or conda to install Python packages. You can't really connect out to public websites over the internet because it essentially cuts out internet access for these pools. If you need it, okay, that's fine. If you don't need it, it can be really limiting. And so I guess it's just a matter of what is the amount of trade-off you're willing to take in terms of additional developer effort or limitation of functionality or finding workarounds for a system, given that the benefit you get out of it is I'm not going to be able to dump all the results into a different storage account, for example. You have the control with data exfiltration protection to say only write to these Azure Active Directory tenants. So even if somebody does find a way to get access to your Synapse workspace and tries to move data out within Azure, they can only do so if you actively allowed them to, which it does help a lot. So if you do have sensitive data, if you are in a situation where this is important, I think it's worth checking the box. But again, like managed VNets, you really do have to enable this at install time. This is not something you can flip on later. It's not something you can flip off later. They just call it VPC restrictions ACLs. VNets allow for customized ACLs too, I imagine. So virtual networks that you create do allow for the customized, the equivalent of ACLs in AWS. So they will allow you to specify IP ranges, using CIDR notation or IP address blocks. They'll allow you to define network rules like ports, accessible, allowable, denied, and control things at those levels. The managed virtual network doesn't allow you to do any of that because Microsoft's managing that. So data exfiltration protection, like I mentioned, severely limits what your workspace can reach. Basically, it's managed private endpoints as well as this thing called integration runtime that is available. We won't talk so much about integration runtimes here today, but that is the way of connecting to something like I have an on-premises data store that I need to get data into Synapse Analytics. Kind of your only way to do it. Allows you to limit what Azure Active Directory tenants to which you can write data, and pools cannot hit the public internet. So as far as those network controls, got a screenshot right there. Just got to point my finger in the correct direction. And if you want to disable public network access, it is a radio button. It's right here. And mind you, this is a thing that you can change later. So the checking the boxes for managed VNet, for data exfiltration protection, that's at creation time. This is after the fact. So I can lock down my network. I can set up my VPN access. I can make sure that everything's perfect. And when I'm done, check that radio button and say, nah, you're disabled. Public network access no longer allowed. And now nobody on the public internet can connect to my serverless SQL pool, to my dedicated SQL pool. If you don't want to go quite that far, there are IP address ranges that are allowable. So this is the other option for, say, I just have one IP address that I want to allow connections to, or I have 2 or 3 IP addresses. Maybe I have a common IP address for my company. This is our outbound internet IP address, and I have one IP address for me because I'm special, and that's about it. One other box here. This checkbox is kind of a trap. Allow Azure services and resources to access this workspace. That checkbox is the easy button for Azure maintenance. Because if you check that box, anything in Azure can access your Synapse workspace. Now, one thing to consider in here is that is anything in Azure, not just your things. And so if you check this box, yeah, if some other Azure client has authorization to your Synapse workspace, they can connect to it. They can access it. Now, they need authorization, so it's not like it's a free-for-all that just because I have an Azure account, I can start trawling through all the Synapse workspaces in the world. But if you're thinking only my company can access this service, and you check that box, that is not the case. So now let's talk a bit of workspace security. And one thing I do want to point out is for pretty much any user of note, you are going to want to grant them storage blob data contributor against the storage account that is hosting your Synapse data lake. Storage blob data contributor essentially allows you to read and write data on the data lake. It's not a really powerful role. It's not an incredibly powerful right, but it is something that almost everything in Synapse is going to require at some level. So the most common problem I run into with security is that role wasn't assigned. By assigning that role, it fixes a majority of problems. In addition to that, there are several role-based access control roles, and I'm going to call these workspace level roles. So this is an IAM role, IAM. That role is service level. Workspace level is a level below, and these are going to give you control of specific resources within Azure Synapse Analytics. For example, the administrator role, full access to everything inside the workspace. Only administrators and people who have the Azure owner IAM role are allowed to assign roles to others. Nobody else can assign roles to other people. For compute resources, if you want to create a dedicated SQL pool or stop one, if you want to create a Data Explorer pool or Spark pools, you still need Azure permissions on the workspace. You're either going to need to be an owner or a contributor of that workspace in order to control compute resources. Spark administrators create and manage Spark pools. So I can spin one of those up, I can stop it, assuming that I have the correct Azure IAM role, owner or contributor. You can work with Spark notebooks, you can work with job definitions in Spark, but you cannot run Synapse pipelines. Also, even though it has the word administrator up there, you cannot grant access to others. Similarly, SQL administrator, you get access to the serverless SQL pool, you can manage dedicated SQL pools, you can control pretty much whatever goes on inside there. You can manage scripts, credentials, linked services, but no pipelines, no access granting of Synapse. So you can create a login within the dedicated SQL pool. You can grant or deny a person access to that database, create a SQL authenticated account within that database. But you cannot say you have access to the Synapse workspace. So you cannot grant rights at that level. Artifact Publisher is highfalutin. I think that's the right way. That's the right term I want to use. It's a highfalutin term. Basically, it allows you to save stuff. You can click the save button. That's what Artifact Publishing is. You can read and manage code artifacts. Code artifacts are scripts or notebooks or pipelines. So it's not just scripts, but you can read them, you can load them up, you can save them. Does not include permissions to run them. So you could be an artifact publisher and write SQL queries to your heart's content and save them all, and may not be able actually to run the things because you don't have rights to the server. Similarly, there's an artifact user that gives you read-only access with no management options. So you could, if you wanted to be really rude, you could actually create a role where There's one person whose job it is to write queries, but they can never run them, and another person who can run queries and can write them, but can never save them. So I don't know, if you want to go full crazy, you can do that with this. Credential user. This is how you access Synapse pipelines, because this is going to let you use secrets within credentials and linked services. Secrets being things like usernames and passwords, security identifiers, those sorts of things that you kind of need in order to access external resources. So in order to run a pipeline, you need to be a credential user. Compute operator. You can run a Spark job. You can view some logs. You can cancel Spark jobs. If you don't like Bob over there, you can be like, hey, Bob's got a Spark job running. I'm just going to cancel it. Now, I don't recommend doing that. I mean, you could if you really wanted to, but probably not rude. It's probably fairly rude. It's fairly rude on the scale. But you can cancel a Spark job. If there's a runaway Spark job, you can stop it. You can run pipelines if you have credential user. You can view pipeline runs and outputs if you have credential user. The monitoring operator allows you to read code artifacts and outputs from notebooks and pipeline runs. You can view the pool details, but you may not run or cancel pipelines or Spark jobs. So the monitoring operator, this might be your first level person in a NOC, where your job is just go read these logs and make sure that nothing failed overnight. If something failed, then page a person who has the right access to do something about it. So that's kind of what monitoring operator is intended for. Synapse Contributor is Compute Operator Plus. Full access to Spark pools, integration runtimes, access to published code artifacts. You can work with them, but you do need credential user. If you don't have credential user, you can't actually run any of the stuff because you don't have the passwords. Finally, Synapse User. Synapse User is the bare minimum level of permission, where you can go connect to a dedicated SQL pool if the SQL admin gave you access. You can go to the Synapse workspace and see that there's a SQL pool that you haven't been granted access to. You may not review code artifacts. You could actually create one. This is the user where you could create something, but you might not be able to save it, which, again, I don't know, that seems a little weird to me. Now, let's talk data in transit. All traffic encrypted using TLS 1.2. You do not need to enable this. It is already enabled. You cannot disable this. I don't know when. I assume it's a when, not an if. I don't know when they'll switch to TLS 1.3, but at least for now, everything is encrypted using TLS 1.2. That is encrypted within the Azure network, transiting between services. That is, when sending data out to you, everything's TLS 1.2. Guaranteed. So that's at the workspace level. Now let's talk about linked services. Linked services are how we connect to the outside world, how we get data in, how we connect to other resources, how we have, make Synapse worthwhile. This can be on premises, this could be in Azure, this could be in other clouds. If we look at the items right over there, I did that thing with my finger again. At the very top left, you can see Amazon Marketplace Web Store. We start off with some Amazon-related items. We go to Azure-related items. In between, there's Apache Impala, which could run on premises. So there's a mixture of things that are in different environments. So it's not just Azure resources. If you are connecting to Azure services, you can connect using a managed identity. Managed identities are controlled within Azure Active Directory. Passwords are automatically synchronized and updated. So you're not having to save all those passwords for service accounts in an Excel spreadsheet somewhere, which not a good idea. But that's another story. We can store keys and connection strings in Azure Key Vault. That's the best place to put these things in the Azure world. Private endpoints, subset of items. You can see right here, not so many. And in fact, they all start with the word Azure. That's because Private endpoints are only for connecting to specific Azure resources. Not all Azure resources allow for private endpoints. Of the ones that do, the ones that are supported by Azure Synapse Analytics are, that's about half of them or 2/3 of them up on the screen right now. It's a fairly limited number, but I think you'll find that for most implementations of Azure Synapse Analytics, this covers the large majority of what you'll be working with. So this covers things like Azure SQL DB or open source databases, Postgres, MariaDB, covers event hubs, covers IoT hubs, machine learning, Key Vault, your data lake. So it's going to hit a lot of the major resources. There may be some that you don't see on here. And by the way, you also do have to have a managed virtual network in order for you to be able to use private endpoints. That's real brief on linked services. So let's talk a little bit about pools, the 3 pools that we want to cover. Pool the first, dedicated SQL. Dedicated SQL pools have their own set of role-based access controls. So if you want to go back like 15 minutes ago, we have IAM roles, Azure service level roles. Then we have Synapse workspace roles. Now we have dedicated SQL pool roles. And if you're familiar with SQL Server administration, these roles are going to be pretty straightforward. You're going to learn, you use logins, just like SQL Server. You can use Azure Active Directory, or you can use SQL authenticated logins. You create users on databases. So logins for the server, users for the database. You get built-in database roles like DB owner, DB data reader, DB data writer. But you can create your own custom database roles. All of that is basically the same as on-premises SQL Server. You control access to objects using permissions. Grant, revoke, deny. Again, nothing new to on-prem people. But quick note on permissions. Permissions are inherited. So if a user is in a role, the user gets all the grants and denials for the role. Revoke resets a grant or a deny. So in other words, I grant Bob access to this table. Later on, I revoke that grant. Bob no longer has an explicit grant. Now, I've not actively denied Bob access to this table. If there is no other role involved, there is an implicit denial. Bob cannot access the table unless Bob has a role that allows that access. But if Bob is like DB data reader, then he has implicit, through his role, he has access to select from that table. However, if I deny access to a table to Bob, then he can no longer access it, even with DB data reader. So deny overwhelms grant. And irrespective of how far the denial is in the inheritance chain. And even if we go the other direction. So here's an example where in a lot of systems, the answer will come out differently. So I want to bring it out. I want to call it out very clearly. Suzanne, because forget Bob. Bob's kind of a jerk. I mean, he keeps running these long Spark jobs. So Suzanne is in the developers Azure Active Directory group. All right, Suzanne is a good developer. We've given developers DB data reader on a user database. So Suzanne, by being in that group, has DB data reader permissions through the group. Now, we don't trust developers to read from the finances table. So we also have a deny select on dbo.finances. Except we trust Suzanne. Suzanne currently cannot access dbo.finances. The reason is she is part of a role that has deny select. So therefore, when it comes down to her level, she's got deny select. So what we do is we say grant select on dbo.finances to Suzanne and nobody else. She still can't access the table. In many systems, a lower level grant supersedes a higher level deny. With dedicated SQL pools, deny overwhelms everything. If you have a deny anywhere in the chain, forget about it, you're done. So regardless of the level at which you're at, Suzanne will not be able to read that table. The way that we can get around this is basically to make a developers who can access finances group. And then we put Suzanne in that group instead of the developers group. So what you could have, you can kind of have a hierarchy where you've got developers, maybe like core developers, and that has select DB data reader. So grant DB data reader. And then you have from there, developers who can access finances, developers who cannot access finances, and then have a deny over on this side, have the grant over on this side, and put people in groups that way. But you kind of have to think this stuff through. And as you get more complicated scenarios with more desires of, well, these certain groups of people can access these tables, but not those tables, this can get pretty tricky. So it's important to keep note of. Put devs at the top of the hypothetical permissions chart. I mean, I do want to have some sassy comment about developers, but yeah, maybe I should have prepped that one better. I could have had a sassy comment in my back pocket. But let's talk database roles. Database roles are pretty close to the same as SQL Server. I already talked about DB data reader, DB data writer, DB owner. You've got a few others. Now there are 3 of them that are special to the dedicated SQL pool. One of them is called DB Manager. DB Manager allows you to create and drop databases. Another is DB Exporter. Create tables, alter schemas, work with Polybase. The third is Login Manager. Create and delete logins. The reason for these is you don't have sysadmin. You don't have DDL admin. Those server level roles don't exist, or you can't grant them. You don't get them, you can't grant them. So basically you have an administrator of the server, and you can grant other people rights based on what they would need. And these database roles in master will allow you to perform some of the actions that a sysadmin would perform under these circumstances. So that is the key difference between the dedicated SQL pool and on-premises SQL Server when it comes to database roles. When it comes to encrypting data at rest, dedicated SQL pool data, always encrypted at rest. You cannot stop it. You cannot shut that off. It is always going to be encrypted using Microsoft keys. Now you may say, hang on, I don't want Microsoft having the keys to encrypt and decrypt my data. To which Microsoft says, first, too bad, we're going to do it. Second, but you know what you can do is you can encrypt what we've encrypted. So you can double encrypt your workspace using a customer managed key. Dedicated SQL pool data will be double encrypted, which it may make it marginally safer because now you have to crack 2 keys as opposed to 1. It will have a small impact on performance, not a huge one though. And it will guarantee that in the event that somebody malicious actually does get access to those Microsoft keys, they cannot decrypt your data because they don't have your key as well. Now, if you don't double encrypt your workspace, you can use transparent data encryption on the dedicated SQL pool. Transparent data encryption works just the same way as it does with on-premises SQL Server. So it has all of the advantages and disadvantages of being really easy to enable and disable, having some negligible performance impact on CPU, and some negligible amount of security. All backups and all snapshots are written to encrypted disk. All Azure disk at this point that involves Synapse Analytics, that's all encrypted automatically. There's no getting around that. So basically, once that data is on disk, it's encrypted at least once. And if you're doing the math, you can realize if the disks are encrypted and the data is encrypted and the customer data is encrypted, there's a lot of encrypting going on. Now you may go one step further and say, you know, there's certain data that I don't necessarily mind if it gets exposed, but there's other certain data that I really don't want that stuff out. The dedicated SQL pool will allow you to perform column level encryption using encrypt by key and decrypt by key. These are functions that have been around for a good 20-something years in SQL Server. At least SQL Server 2000, probably 7, maybe even before that. You're going before my time at that point. This is where even if I have select access to a table, if I don't have the ability to open up the key and use that key, I cannot decrypt the data. So it's good for, say, somebody lost their credentials, somebody accidentally gave away their password for a dedicated SQL pool, and a bad guy gets in. If that person doesn't have access to decrypt the sensitive data, they're going to see encrypted garbage. So it is one extra level of protection. If you do want to use column level encryption, there are 3 options within Azure Synapse Analytics: AES 256, 192, 128. So those are the different bit rates. Just use AES 256. There's no real advantage to 128 or 192. 256 is solid, is fast. You're not losing anything by using it. I mean, you're not using like 15-year-old hardware where there would actually be a practical difference in speed. So just use the good one. The other 2 are still okay, but just use the good one. On-premises SQL Server allows you to do things like DES, triple DES, and RC4. Don't do that on premises. The only reason it's there is because back in 2000, those were reasonable options. They are not reasonable options today. Don't do that. Azure Synapse Analytics does not even support DES, triple DES, or RC4. So you can't even choose to make a bad decision in that regard. One other thing, always encrypted. In SQL Server on premises as of 2016, not supported in the dedicated SQL pool. So if you want encryption, you will have to use column level encryption versus always encrypted. Quick idea of how this thing works. First thing, we need a master key. We need a certificate. So I have a master key. I can secure that with a password should I so desire. I create a certificate with some subject. I create a key using my algorithm AES 256 and nothing else because I listened on the previous slide. I'm encrypting based off of the certificate. So the certificate is built off of the master key. The symmetric key built off of the certificate. I add a column to dbo.people. People has a last name column already, but we said, oh, we're going to add an encrypted version of that name. Then I want to open the symmetric key, and I need to decrypt using the certificate personnel cert. So whoever is doing this needs to have the correct authorization to access this certificate. And typically what we do is we can use things like module signing. We can also say grant permissions on stored procedures with execute as owner, and that's one option. You can do proper module signing. Couple of options there. But let's say I do have access to this. I should have access to open the symmetric key. I can update the people table. I can set the last name encrypted using the encrypt by key function, which takes in the key that I need, personnel key, and the string column, last name, and then convert that to a var binary 160 and write it to the table. Then, if I want to read that data later, I can select, after opening the symmetric key again, I mean, this is assuming I'm in a different stored procedure, I'm in a different context, it's later on, whatever. Select from dbo.people, I can convert the last name encrypted using decrypt by key to get the binary out of it, the decrypted binary, convert that to in varchar, and I have my last name. So this is how I can get a decrypted version of my data if I, say, have a need to store that as sensitive information. Dynamic data masking is an option in the dedicated SQL pool. It is not an alternative to encryption. Basically what it does is it replaces the output of select operations with a mask. It'll block out a sensitive field. Say you have email addresses that you want to display on a form, but you don't actually want to display the full email address. Well, people with the ability to query the table can write queries that will allow them to expose what the actual details are. So it is not encryption. It is not a security mechanism against people with direct query access. What it is a shoulder surfing security mechanism. If I have a form up, this is going to automatically mask certain columns, certain information that we've set up to do masking, and will prevent somebody from just looking over and seeing on the screen what that person's social security number is. Otherwise, it's not really intended for any other security purpose. Row level security is intended for a security purpose, and this is to allow you to define which rows an individual may see based on group membership or other access control. These are called filter predicates. Essentially, you have a where clause, a predicate, and we're saying, okay, well, based on your access, you only get to see those rows. Assuming that you have some column that you can use to filter, we can create a function that returns 1 if the user can see the row, 0, or null if the user cannot. We create a security policy that ties that column to my function, the filter predicate, and for a query, we get our results. But this will have a performance impact. That performance impact will probably be pretty large. It might be so large that it makes it so you don't want to use row level security. Just something to keep in mind. But let's say you want to use row level security. Well, you can create a login. And the example that I had here was this idea of collecting statistics, baseball stats, and allowing people to access for their own team. So if we had an Atlanta user, we had a password for that Atlanta user. This is a SQL login. We create a user in the user database, and we grant select on dbo.pitching to that user, and maybe to a specific person as well, or to a specific AD group. We may have a schema, and I create a function. That function, given a team ID, is going to say, does the first 3 characters of the username match the team ID? Or maybe we have one person, Alicia, who's allowed to see specific teams, Toronto, Seattle, and the Royals. So whatever the logic of this function is, we create this function and then create a security policy that says on dbo.pitching, we are going to use team predicate using the team ID column on the table to limit down who's allowed to access what rows. Then when either Atlanta user or Alicia goes to select from that table, each one of them can write the same query and they will get different results. ATL user will only see Atlanta information. Alicia will only see Toronto, Seattle, and Kansas City information without having to have any specific filters in here. So row level security is a really cool idea. The only problem is it will have a performance impact, and that performance impact will probably be too large for you to use in most circumstances. It's the real downside to it. Something that is kind of nice within a dedicated SQL pool that you don't get anywhere else, data discovery and classification. So data discovery and classification here, and I'm going to temporarily drop my camera because there's a good column on the right side. This is going to allow you to classify specific columns and tables using different sensitivity levels. So on the screen here, I've got the automated results. It went and looked at my tables and said, hey, on the people table, there's a birthday, a birth city, and a death city, which birthday may be confidential under GDPR. City of birth and city of death may be confidential information. In this case, this is not confidential information. It's publicly available information on baseball players. But I can select those boxes and say, yeah, you know what? That is sensitive data. And what happens is that as people write queries against that sensitive data, we can get audit information on that. So I can see who has accessed sensitive data. I can see the queries that they wrote. I can see the results of the queries that they wrote if I want that information. But what this allows us to do is check to see, are people misusing their information, their access? A classic example of this in practice is if you work in a hospital setting. If you're a nurse, you're working on a given floor in a given ward and on a given shift, and you are allowed to access the information for the patients on your floor in your ward for your shift. You can't access anybody else's information. If you start searching around for people, you have heard that very famous person is in somewhere in the hospital, and you go searching in the database for very famous person, what usually happens is that you get walked off the premises, they take your badge away, you're fired because you've just broken the rules for that hospital. Because that's also a HIPAA violation, and the hospital will get a very hard smackdown if they don't stop you immediately. So they take that kind of thing extremely seriously. This does allow you to do much the same thing. And to your answer, Mark, does this tie into SQL audit? Yes, it does. So this is going to tie into SQL auditing, and you can see the function here, fn get audit file. All of those files are stored in blob storage. So instead of storing it on local disk, it's in the blob, and you don't have to read it from within here, within the dedicated SQL pools query operation here. You can actually read that data into Data Explorer and parse it through KQL. You can just load the files up some other way and get that information. Now let's talk about the serverless SQL pool. The serverless SQL pool also has role-based access controls, logins and users, grant, deny, and revoke, role assignment, custom roles. Hey, same thing. I'm not going to walk through the same slides. But there's actually a lot less to do here because you don't insert, update, merge, truncate, delete, or modify data. So you don't need to grant people rights to do that. They can't do it. We can't create normal tables in a serverless SQL pool. So you access data via OpenRowset. You create external tables using Polybase. When you create those external tables, they're read-only. There's an exception to it. But OpenRowset, you need the Synapse user RBAC role. You need grant administer database bulk operations in the serverless SQL pool, which sounds kind of scary, but really it's not. In the serverless SQL pool, that role basically is grant OpenRowset. On premises, it allows you to do a bit more. It is a little bit scarier, but this is what we need if we want to run OpenRowset and write select queries to get data through the serverless SQL pool. That's kind of the bare minimum that you want to offer to people doing ad hoc processing. With Polybase, you need Synapse user, RBAC role. If you want to create or drop external tables, you need control on the serverless SQL pool. That is powerful. No way to sugarcoat that one. Just like control on SQL Server on premises basically is you can do almost everything. Control in a serverless SQL pool, you can do almost everything. If you want to read from these tables, you need DB data reader, you need DB owner, or you need to be granted explicit select access to the table. So if you're just querying data. Let's say that you've got a DBA who is setting up external tables. The DBA has control, and they create those external tables as part of a deployment script. So maybe the deployment user has control. End users just need select on the external table in order to read the data. They don't need control. They only need control if you want them to create or drop external tables. One quick recommendation. The serverless SQL pool reads data from your data lake. You can use things like SAS tokens or access keys to access those data lakes. Just create a managed service identity. So you can use the Synapse managed service identity that is created with your Synapse workspace. And if it has the appropriate rights to query, if it's got storage blob data contributor or storage blob data owner, then you can access that data lake via your MSI and not have to worry about it at all. Now, if for some reason you can't use a managed service identity, you can create a SAS token. Shared access signature or SAS tokens grant you specific access. You can narrow down that I wish to give access to these folders, these files. I want to give you these specific access rights like list, read, write, delete. I can narrow down to specific IP addresses. I can limit you to a specific time frame that this will be available for the next 1 day or the next 99 years. And I can force you to use HTTPS, no HTTP connections. So if you do want to create a SAS token, there's a pretty easy way to do it using the AZ CLI. I've got an example here where we're creating one for Synapse, forcing HTTPS. We'll let you to list the directories. We'll let you read and write anything in there, and it expires in 30 minutes. Nothing too crazy, but this will give you a SAS token that you could use and feed it in instead of identity equals managed service identity. Now let's talk Spark. When it comes to Spark, there are two different types of isolation that are relevant. First type, network isolation. Spark pools in their own virtual network. Remember, that happens if you turn on managed VNets. You get that for free. The other one, physical isolation. If you want this, each Spark pool will get its own physical box. Nobody else is using your physical box. But you must use the XXX large node size, which, by the way, costs XXX large as much money as regular nodes. That is very expensive. There's probably a customer who demanded it of Microsoft and threw enough money their way for Microsoft to say, yeah, all right, cool, we'll do that. I'm never going to pay for this. I will never work at a company that will pay for this. This is prognostication here. It is very expensive. But you know what? If you absolutely need it and you've got that much money and you really need this operation to be physically isolated, it's available. If you want a Spark pool, you've got to be a Synapse admin or a Synapse Spark admin. And remember that you also need to have contributor or owner on the workspace as an IAM role so that you can work with compute resources. If you want to run a Spark notebook, you can be a Synapse admin, a Synapse contributor, or a Synapse compute operator. Spark notebooks allow you to execute code in a fairly simple fashion using languages like Python, like Scala, like Java, or like SQL. If you want to use the data lake, in addition to contributor or owner of your of that workspace, if you want to create those Spark pools, to use the data lake, we need storage blob data contributor on the storage account. Lake databases are going to let you share some metadata between the serverless SQL pool and Spark pools. Think of a lake database as a way of connecting those data lake-driven resources. So I may have some common metadata of table structures, view structures that I want available within multiple Spark pools and my serverless SQL pool. I want them all to see the same thing. Lake database security is really at the storage level. You give read on files, execute on folders that'll let people read that data. Database creator is the owner. Database creator has all the rights. Accounts with Synapse admin or Synapse SQL administrator will have permissions as well. Why SQL administrator? Because of that serverless SQL pool. If you create a Spark pool, it will come with a variety of preloaded libraries. It will probably not have everything that you want. Therefore, you can install Scala or Java packages or Python libraries after the fact. Python libraries, you can use pip, you can use conda. Scala and Java, they don't support Maven. However, you can load jar files. There is the Synapse workspace. It has a manage menu that will allow you to preload jar files that you upload. And with Synapse, you can use pip, specify a requirements.txt file, and it will go and install as much as it can. We can also use wheel files, WHL, similarly to jar files from Java and Scala in the manage menu in the Synapse workspace. But if we want to import a library, what we need is storage blob data contributor on that data lake storage account. Now, installing custom packages means that you are taking on the risk that the package you install is not going to be malicious. Vulnerable packages happen, even if it's not explicitly malicious. If I want to use the .NET world, there is a denial of service attack that is available in any version of newtonsoft.json prior to 13.0.1. So if you have a version that is 13.0.0 or earlier, there is a denial of service attack that is out there. Your .NET services are vulnerable. That's not because of anybody doing anything maliciously. It's just, development happens. So if you want to mitigate this, you can do things like custom conda channels. So what you can do there is say, our security team has pre-vetted these versions of these packages and said that they are okay. And you can read from that package library instead of the public internet. You can have versionless package specifications in your requirements.txt to make sure you're getting the latest version so that you don't have an old version that is got a vulnerability. Of course, that has its own downside risk that a lot of packages tend not to be as backwards compatible as we'd like them to be. So you may have some perfectly working code today that breaks tomorrow because version 2.6.3 of blah, blah, blah library broke their API, and therefore your stuff's broken. If you have data loss protection enabled, you cannot access external websites. That includes conda channels. If you want to get those packages, store them on the data lake, load them up as you create the Spark pool. There are some extra steps involved. When you are working with Spark pools, you can use SAS tokens or connection strings or whatever to connect to external resources. Definitely keep that stuff in Key Vault. Use a library that's called the token library to access these secrets. Token library is a package that is installed in every Spark pool and will allow you to get secrets from Key Vault very easily. So highly recommend you dig into that if you're using Spark pools and you need any sort of access to external resources. Let's end this with a quick discussion of a few additional tools. Microsoft Defender for SQL. This is obviously not a Synapse specific thing, but it is pretty useful. And there are two key components that relate to Synapse workspaces. One is the SQL Advanced Threat Protection. This will give you alerting on suspicious events. I've seen this pop up. For example, a buddy of mine, this is a different context, but a buddy of mine went to Bonaire for some diving. And he was doing some work while down there in between dives. And then got a call from the security admin for the company saying, hey, are you currently in Bonaire right now? Because Microsoft fired off an alert that there's somebody who's logged in as this person coming from a location that is not the person's normal location. So they can track where you normally log in from. They can figure out that, oh, this is yes, you did successfully authenticate. You put in the right username and password, but you're not normally here. And security people can find out, yeah, this is a login from an unusual location, and take whatever necessary action they're going to take. So in this case, a quick phone call cleared it up. Yes, that is really me. Yes, I am enjoying it. And everything's good. SQL vulnerability assessments. These run weekly and will give you essentially a score that says, if you do these things, you will make your dedicated SQL pool more secure. You will make your serverless SQL pool more secure. So nice weekly email that you get. Azure policy, another thing that's outside the Synapse workspace, but it'll help you enforce organizational standards. You define business rules in JSON, you apply them to Azure resources, and it can prevent certain activities. It can automatically adjust things to stay in compliance. You can audit if your configurations are different from what you expect. You can log if somebody has made a change, or even deny those changes. There are several policies that are relevant to Azure Synapse Analytics. And if you want a copy of these policies, let me drop a note right there. And if I bump up just a little bit, like here's an example. Azure Synapse Workspaces should only allow outbound data traffic to approved targets. So are you using data exfiltration protection? And if I were to click on the link here, it's going to take me to a location where it'll say, hey, here's the policy that you can create, the JSON for it. And, I can use that in order to ensure that any Synapse workspace has data exfiltration protection enabled on it. You can't create one without it. So over the course of this talk, we've looked at quite a few ways to secure an Azure Synapse Analytics workspace. I gave you a really broad overview covering a lot of topics in not a huge amount of depth. I have an 8-hour training that is available through the EC Council and their Code Red series on securing a data warehouse in Azure Synapse Analytics, in which I go into much more depth on all of these topics. So you can imagine, considering that it's about, 6 times as long as what we had today. That is a paid training, so I'm not going to push it any further, but if you are really interested in that, it is available. If you would like to learn more, if you want to grab these slides, or if you'd like to grab links to additional resources, please do feel free to hit up csmore.info/on/lockdown. And if you do want to reach out to me at some point in the future, you can send me an email, or you can find me on Twitter, where I'm there like once a week or so, maybe. But with that, I want to say thank you so much, everybody. If there are questions, I'm happy to stick around. And thank you for coming in, KRAM. Otherwise, if there are questions, yeah, let's talk about them. Very briefly, remember next week we do have our business intelligence and data science meetup, where, I'm pulling it up right now so that I don't get any of the details wrong, we will have Heidi Hastings talking to us about sensitivity labels and what they do for reports and documents in the Purview world and in Power BI. So should be an enjoyable experience there. But if there are no questions, of course, this will go up probably sometime this week, depends on how busy I am. But the video will be available. You'll be able to access it later if you wanted to go back through it again. And with that, I think we're going to call it a night. So everyone, until we talk to each other again, take care.